Okay. All right, everybody see a slide that says modern SQL Server features make life better?
Yes, sir.
Good deal.
Yep.
All right. So welcome. Thanks for joining us in the St. Charles SQL Server Meetup. And I'm glad everyone could make it tonight. We're going to be talking about modern SQL Server features that make life better. For those of you who don't know me, here's a little slide that gives you some information. I didn't know I was getting into IT in February 2008 when I took a job managing a key application at the business I was at the time. But so got my start, into SQL Server, and been 12 years. I started out using SQL Server reporting services to build custom reports for my employer. I was really fascinated by the SQL Server engine underneath the application that we were using. And at the time, I also got the chance to learn SQL Server transactional replication as part of supporting a key application. Some people would say, wow, poor you, but oddly enough, I was really interested in replication. It made a lot of sense, and I was kind of fascinated by it. I did a lot of self-study, and 4 years after starting with SQL Server, I earned my first certification, and I earned 2 more earlier this spring. I would encourage you just to take a look at my blog at leemarkum.com, and those last 3 bullet points there are just ways that you can reach out to me and contact me if you're interested. And currently a cloud database administrator at Upland Software. A little bit about me. So our agenda this evening is to touch on the following categories of features. We're going to talk about high availability and disaster recovery, and we'll review some performance related features in SQL Server, followed by new aspects of the product that I think are helpful for troubleshooting. We'll look at some useful changes concerning permissions, and then finally we'll cover some helpful T-Sql changes as well. I do want to set some expectations. This presentation can't go in depth on all the features that I'm going to talk about, partly because any one of these features could be an entire presentation unto themselves. I am mostly trying to just introduce features to you and do so in a way that highlights why it makes your life better as a SQL Server professional. I'm really only considering features from the database engine and not integration services, reporting services, or analysis services. These have all had enhancements that we could talk about, but I don't really work in those realms. So it's not something that I want to touch on in a presentation. And also, there are a lot of features that I could have chosen from for the presentation. If your favorite feature isn't in the presentation, we don't talk about it, feel free to bring it up at the end and we can talk about it then. We can certainly mull over ideas and about additional things that could have been included. So how did I decide which SQL Server versions to discuss? I mean, there are so many now. Go all the way back to 6.5, I suppose, but this is about modern SQL Server features. I looked at a website that I often use called SQLServerUpdates.com. Brent Ozar maintains that. And as a part of maintaining that, he talks about different patch releases and what's in those releases. And he gives you an end date for the extended support for that particular release. So extended support for SQL Server 2012 ends next summer. This means no more patching for SQL Server 2012. Even security patches will stop after next summer. So in my opinion, that means really the minimum version that you should have in your environment is SQL 2014, especially if you're going to create a new build. SQL Server 2014 actually goes out of extended support in July 2024. So you have some time there. So I'm going to cover features in SQL 2014 and above in this particular presentation. The exception to that is going to be always on availability groups. And I'll mention column store indexes as well, which both appeared first in SQL 2012. So I'm breaking the rule for these features because they continue to evolve in some significant ways after SQL Server 2012. And also, frankly, because I'm a big fan of always on availability groups. And I think that in the right scenario, column store indexes can be pretty amazing. So this first category that you see here is going to be high availability and disaster recovery. And I have a couple of links at the top here. One goes to Microsoft Docs. It's just called "What is an Always On Availability Group?" So if you're not familiar with it at all, you can look at that a little later and get some more details about that. There is another link there to a blog post I wrote called "My Availability Group Database Isn't Synchronizing." And that is meant to just provide some basic troubleshooting information about how to manage a common scenario in always on availability groups. This particular feature is built on Windows failover clustering. And a Windows failover cluster is just a logical grouping of Windows machines that work together to support one or more applications. In the screen capture that you see on the slide, multiple Windows nodes are in the same Windows cluster. And each one of those nodes has its own storage. For availability groups, there is an availability group name that represents a collection of databases that all fail over together. So in this case, in the middle of the screen, you see a gray box, and you have primary on the far left. You have primary replica followed by 4 secondary replicas. Each of those are on their own nodes, but collectively they're in this group called MyAG. And so that availability group is essentially a single unit of collection, or a single collection there. It is recommended also that you have what's called an availability group listener to also be set up. It's not depicted on the slide. And the reason for that is that I got this slide from, I believe it's SQL Shack link, which is part of the slide deck. You'd be really hard pressed to find, amazingly enough, a picture that actually has all the components that would include an availability group listener. But what that is simply a named connection that your applications point to so that they can talk to the database. It really functions in the same way as a virtual network name for a SQL Server failover cluster. So with an always on availability group, SQL Server can automatically fail over the entire group of databases from the current primary to one of the secondary nodes in the event of a server restart or an unexpected issue that causes an outage. This is really helpful when applications depend on more than one database for proper functionality, and it provides an advantage over something like log shipping or mirroring, which do not have the capability of automatic failover for a collection of databases. And in fact, log shipping doesn't have automatic failover at all. So in this way, I think availability groups as a modern SQL Server feature definitely make life better for the SQL Server professional. Unlike a SQL Server failover cluster, which requires shared storage target, and so by default leaves you with a single point of failure, the always-on availability groups allow for data movement between the participating nodes to each node's own storage. So in the picture, you look on the left, you have a primary replica, and the data from the primary replica is being moved or replicated over to each of the secondary replicas. So there's a copy of the database stored independently on each one of those nodes. And so then by default, you get redundant copies of the data. Now, if you're using something like SAN for storage, which is of course going to be very common, you're still going to have to coordinate with your storage person so that she can ensure SAN storage is redundant, or you can also have one or more computers in a remote location on a different SAN for the case of disaster recovery. This leads to another thing about this feature that makes life better for you as a SQL Server professional, is that disaster recovery to a remote location is really pretty easy to do, and I'll show you that next. So what you're looking at here is a multi-subnet availability group. And this picture is from SQL Shack. So there's no need to set up log shipping for a bunch of databases, no need to set up transactional replication, even if your table design would support that, because as many of you might know, transactional replication requires that your tables have a primary key. Now, all the tables should have a primary key, but we all know that we've been in environments that don't always follow best practice. And so replication sometimes isn't even an option for you. So the easiest way to set up disaster recovery using availability groups is what's called a multi-subnet failover cluster, like I mentioned before. In this particular scenario, you would add one or more computers to an existing Windows failover cluster, and you would add these nodes over in a remote disaster recovery location on a different part of your network than the initial cluster, thus the multi-subnet part. So on the left-hand side, you might have your primary data center with a primary and a secondary. And there's replication between that primary and local secondary that's real-time, it's synchronous. And the computers in disaster recovery are part of that same Windows failover cluster, and they also get copies of the data from the primary that is in your local data center. You'll set up an availability group listener, both for the local availability group or the local set of nodes, and you'll set up another one for the nodes in the remote disaster recovery with a matching IP range that goes along with those remote nodes. Now, when you do this, I would definitely recommend changing the setting called Register All Providers IP. It should be set to a value of 0 so that it's actually off. This prevents your client connections from trying to reach both availability group names at the same time. You don't want them doing this because the client trying to reach out to your disaster recovery site is going to time out, and you don't really want that. There is another kind of AG called a distributed availability group, but it is by far the more complex way to set up disaster recovery with always-on availability groups. It has its place, but again, I'm trying to give you just a more of an overview, or enough of an overview about functionality so you can see how this helps you. One last thing about this feature of SQL Server that makes life better is the built-in ability to make the databases in the availability group readable. So this makes them available as a source for querying for near real time for things like reporting, and like if you have a Power BI or a Tableau or something like that in your environment, you could actually point that product to readable secondaries, and all of that traffic, all of the reporting load that would normally be on your primary server is now being handled by one of the secondary nodes that you happen to be using for that. Now, you could do something similar. Select queries can be done with log shipping, but there are some complications with that. You can do it with mirroring. If you use a static database snapshot of the mirrored database over on the secondary, But availability groups, they just easily give you readable secondaries that allow you to report on data in real time. I just think it's so much easier to set that up than try to manage log shipping and make that readable, or in mirroring where you're having to manage database snapshots that can become a little complicated. So another way there that availability groups are going to make your life a little better. Are there any questions at this point before I keep going?
No, I don't think there are. Well, at least not in the chat.
Okay, thank you. So as a continuation of this particular category of high availability and disaster recovery, we have a new feature in SQL Server 2019 called Accelerated Database Recovery. So what this feature does is it uses something called a persisted version store that exists in each database. And that persisted version store allows SQL Server to roll back faster via logical revert. And we'll talk about what that means exactly. The persisted version store keeps the previous version of a row so that if a transaction is aborted, SQL Server can simply replace the uncommitted row change with the previous version of that row. This is quicker and different than actually replaying the records that are in the transaction log in order to undo a change. There's also a mechanism that sweeps the database every 60 seconds. And what that does is it eliminates row versions that it doesn't need any longer. So for instance, if you look at this record on the screen, I have a sample record from a database called College Football that I created. And we have a record for a coach named Lincoln Riley. He coaches the Oklahoma Sooners football team. And if I were updating this particular record because I needed to change the overall record column, for example, to keep it up to date with the most recent ending of the college season, and all of a sudden, the database shuts down, or the SQL Server instance shuts down, accelerated database recovery will allow me to simply, or allow SQL Server to simply revert the row to the previous version. So if we scale that out, let's say we have an application or PowerShell that's going to run scripts for us, for example, maybe to update the entire database. So we have roughly 300 records in here of coaches and different schools and their records, and we're going to update all of that. So let's say that we're in the middle of updating that, and then someone realizes that we're running the wrong script. Well, what do you do? When you might be trying to decide, well, should I abort the script and then just let SQL Server roll back all those changes? Someone then suggests, well, if we just restart SQL Server, it will actually run crash recovery when it starts back up. And they suggest to you, well, I think that's going to be faster than trying to undo all the changes. So somebody restarts the SQL Server. And 10 minutes later, you're still waiting for this database to come online because it's rolling back all the changes from the transaction log via the traditional rollback and recovery method. And you're thinking, man, I thought that was going to be fast. Well, with accelerated database recovery, your life is better because it will be fast. SQL Server is going to come back so much faster in that particular scenario because accelerated database recovery simply reverts the changed rows to their previous state rather than searching through the transaction log, undoing or rolling back uncommitted changes. So we're going to move on to the performance category at this point. And there have been a lot of changes. We can only, again, talk about some changes. We only have so much time. Intelligent query processing. So that is actually a collection of new database engine features that were introduced in SQL 2017 and continue to be enhanced in SQL Server 2019. So memory grant feedback is part of this collection of changes. And what it is meant to help with is scenarios when too much or too little memory is requested for a query. So when you submit a query or an application submits a query to SQL Server to run, a request for memory is actually made before that query can even run. That a memory grant that is too small can occur when SQL Server underestimates the number of rows involved in an operation. And then a spill to disk over in TempDB actually occurs so that those extra rows that weren't expected can be processed. So when this happens, in these newer versions of SQL Server, the engine now adjusts to provide the query more memory the next time it sees this query. And thus it allows better performance by avoiding the spill to TempDB. So let's take a look at lightweight query profiling. And this is actually a tool that gives you feedback on row counts for operators when or within a live query plan. It's the information that's shown in the button that's called Show Live Query Stats in SQL Server Management Studio. The catch with using the option in SQL Server Management Studio is that you have to turn on the button and the option before you actually manually run a query in SSMS. Well, that's not always possible. Because you may be having a performance problem right now and maybe you don't have the query. It just slows things down to have to do it that way. But what lightweight query profiling will do is display the information, the performance information, after the query has already started running. So I'm going to show a demo of that and would help us answer the question, should I kill this query? This particular demo comes from code made available by Bob Ward and his GitHub, and it goes along with his book called SQL Server 2019 Revealed. So we'll take a look at that. All right, so over here in SQL Server Management Studio, you should be seeing window here where we're actually going to do some work with the Wide World Importers database. And this is a new sample database that you can get off the internet simply by looking it up and doing a download. And Bob's code creates a new table called Invoice Lines Extended. It's going to create an index and initially load 228,000 rows and then do some work to extend that out to 3.6 million rows. So then I've already actually completed these particular parts of it. So what we're going to do then is run this query called My Smart SQL Query, which, as you can probably tell, probably isn't going to end up being very smart. So we'll get that running. And over on another window, we will run some additional queries. So this query is just going to show you what is active right now, what's running, status, wait type, and you also have a CPU time and logical reads. And if I click execute a few times, you can see that the CPU time is continuing to climb and the logical reads is also continuing to climb. So what the lightweight query profiling is going to do for you is shown in this next query in the sys.dmexec query profiles. If you run that, you'll see that what you get is a list of operators that are occurring within the query plan, row estimates, and you see these really large estimates here. And then here you have the row counts of what's actually been processed so far. Well, there are huge differences between what is already processed and how much it thinks it has left. It's a good chance this query is going to be running for quite a while. So it's probably a candidate for being killed. If you look back at the active query information, you have a show plan here. And what that's going to show is we have this nested loops with a no join predicate warning. So if I come back over here to my query, it's still running. We're doing a join on sales.invoices to sales.invoice lines. Or are we? If you look at this, you're actually just joining sales.invoices to itself. You missed the join to the table that you have in the query. So you're missing this join. It's just going to loop back on itself almost infinitely. And so this is certainly a query that you're going to want to kill. And if you come back over here and look at the lightweight query profiling, you can see you still haven't made all that much progress. You're still miles away from these row counts matching what's estimated. So we're going to go ahead and stop that particular query. Any questions about that? No? Okay. So the next thing, let me get my slides going again. So the next thing I wanted to mention is there is a last execution plan dynamic management function. And that is from that sys.dm exec query plan stats that you see. It is new in SQL Server 2019. The lightweight query profiling has to be on. You can turn on this functionality in globally with across your entire SQL Server instance for all your databases by using a trace flag 2451. This particular function can be also turned on at the database level. So there's a script there on the slide, and you can turn it on for individual databases that you might want to do this with. And what it does is it just gives you the last actual plan or estimated plan with runtime statistics for a particular query. And this can be really helpful to try to troubleshoot why is a particular query running differently now. You can actually get the current plan and see what might be different about it. So that's another feature in this performance category that can really just make your life better as a SQL Server professional. So still in the performance category, we're going to look at Query Store next. So Query Store was introduced in SQL Server 2016, and it really solves the challenge of persisting performance data over time. Prior to Query Store, there was the management data warehouse in SQL Server, and that feature can still be enabled, but Query Store is, in my opinion, superior to management data warehouse. Query Store is easier to turn on and has very little management that is needed for it, unlike what I experienced when I experimented with the management data warehouse. Outside of that, you had to have a server-side trace collecting data, or later when extended events became available, extended event sessions capturing performance for you. Now, both the server-side trace and an extended events, those methods, particularly server-side trace, have significant or can have some significant overhead depending on what you're trying to capture, especially for things like query plans, for example. You could also do things like record the output of Atom Mechanics SP underscore who is active to a database and review that information later. A lot of times it's recommended or suggested that you do that on every 15 minutes, every 15 seconds, or every 30 seconds. Well, that's fine, but it leaves gaps in your performance information. I don't really think that any of these approaches gives you the kind of insight that Query Store provides. And all of these previously mentioned options are things that you'd have to manage for yourself on a regular basis, or you'd have to put a fair amount of effort in just to set up and capture what you're interested in. There'd be a lot of trial and error to make sure that you have the information that you really care about. So I think Query Store just makes life better simply by freeing you from having to create and manage your own monitoring processes, or convince your boss to buy a pricey monitoring software from a third-party vendor. Now, I like third-party vendor software for monitoring. It works fine, but some employers, when you read their job postings, they want you to know how to do this with native monitoring tools. They're not going to buy a third-party tool for you. You're going to have to use something native, and I think Query Store gives you something to do that with. So let's actually go ahead and look at some information collected in the Wide World Importers database when we did the demo on lightweight query profiling. So back on my screen, if we drill into SQL Server Management Studio Wide World Importers, you have this folder here called Query Store. And you have a bunch of canned reports that you can open up. And you just right click and then click on view top resource consuming queries for this particular example. So I actually go ahead and run this. And by default, it just shows you information for the last hour. And you get this nice graphical representation of a query information that in this case is really hard to miss. And this particular one is focused on durations, milliseconds total. You get a query plan and you get a plan ID information. If you click configure, you can change the way this report slices its data. So you can look at things like execution count, CPU time, milliseconds, logical reads, etc. And you can change it based on a number of things like, the total, min, max, average. You have some suggested intervals that you might be wanting to look at. And you can also come down here to custom and back this up to a particular day, a particular hour. I'm going to go back just a couple of days and we can look at information in here. And when you hover over the query, you get things like the query ID, that's a unique number to Query Store, and you can use that to track this particular query over time. You get total duration, execution count, and the number of plans that are involved. If you hover over the square on the right side where you have the plan information, you get things like execution type that was canceled, was the plan forced, how many times did it run, what was the average, and the min and the max for those particular executions. So a lot of good information in here. You can actually also do things like compare query plans using Query Store, so that it will show you differences if there are different shapes of the plan because different operators were used. You can also see if the query plan shape is the same, still see information about differences in rows that were processed by operators. So very helpful feature here. You also have a report for query weight stats that is right here. So when you run this report, I ran it for just the last week to give me a little more data. You get things like categories, network IO, parallelism, buffer latch, memory, and those sorts of things. And again, it's really easy in this case to see what has been using up resources. And if you double click this, then again, you can go in and see what are the queries that have been contributing to this particular kind of query weight. So really useful information here. And here's a case where you have different query plans and you can hold down Shift and select them because you might want to compare. And then you have compare the plan for the selected query in a separate window. And you hit this button and This information belongs to what's up here, and this information is the bottom plan. So by examining this, again, like I said, you could see if the query plans are of similar shape or not, and look at things like row estimates and that sort of thing in terms of query performance. So that's a quick overview of Query Store and kind of some of the things that it can do for you. So come over here back to the slide. The weight stats information that I talked about is not available in SQL Server 2016. That actually becomes available in 2017. There are custom capture policies that become available in 2019 that allow better control over what's being captured, so Query Store performs better. And Aaron Salato actually talks about that particular part of Query Store in the presentation that we recorded, I believe last month or 2 months ago. You can also force a plan if you find a particular plan produces better performance for a particular query. So that's kind of Query Store in a quick overview, nutshell kind of look. Any questions about that? Okay. So then the next category that we're going to look at is going to be troubleshooting. The most upvoted request of all time is, please do something about this very vague message that just says my data won't go into the hole I'm trying to put it in. So I've dealt with this scenario many times where we have a SQL Server agent job, it fails, and the message that you get in the SQL Server agent history is the string or binary data would be truncated. And you think, well, that's just great because this table is huge, it's very wide, it has a lot of columns, and it has a lot of rows. So when this generic message occurs, then the developer, DBA, and SQL Server professional, somebody's got to go digging through the data and look at column data types in the table, try to figure out what the offending column is, what the offending value is that's in that column. And so this error message really is almost useless. It's just kind of like saying something broke. So in SQL Server 2019, you get verbose truncation warnings where you get a better message that says string or binary data would be truncated in table X, column Y, and the truncated value is 1, 2, 3, 4, 5. Wow, that's really useful, helpful information that helps you zero in on what exactly my problem is. This can be turned on in SQL Server 2017. You just have to use a trace flag to do that. It is by default available in SQL Server 2019 when your database is in the compatibility level 150 for SQL Server 2019. Kind of next in this troubleshooting scenario is temporal tables / system version tables. This became available in SQL Server 2016 and can help you kind of answer questions about what happened to the data and when. There is a history table that keeps a complete record of updates and deletes to your data by tracking versions of rows based on a time period. The time range start and time range end values represent the time range when the values in the history table were in the source table, which is also referred to as the temporal table. So why would you use this? You would use this for things like tracking price changes for products over time, for example. You can analyze those changes for trends. You can recover versions of rows before oops changes were made with, and you can do that without the need, there's no need for a restore operation in order to try to fix oops changes. So I actually use this feature in a very specific scenario to try to give myself a little bit of protection and the ability to troubleshoot what happened to data when I was anticipating bad things were going to happen. I worked at a location that had a lot of power business users, and I'm sure that's pretty common. In this particular case, the person was using Microsoft Access. It's connected directly to the SQL Server database to manage the data that was part of his division. There was data that his division managed. And so in a sense, they kind of owned the data, it was theirs. And I was visiting with this person at his desk, talking to him about this process. And he was showing me what he was doing with Microsoft Access. And essentially he just types right over the values that he sees in Microsoft Access and commits them to the SQL Server. So as we're talking about this, a colleague comes up and the three of us begin talking about this process. And the colleague looks at the other person's screen and he says, so-and-so, that change you just made is actually wrong. And I thought to myself, this is why I don't want you to do it this way, because there aren't any protections. You can literally change anything at any time, and you don't have a way to know that you did it. So what if this was on a grand scale and he changes 1 million rows all to the wrong thing? We're going to have a tough time trying to troubleshoot this and figure out when and try to revert it and all of those kinds of things. Well, the temporal table and system version tables gives you a way to see what happened and when particular versions of rows existed in your temporal or source table. So let's go ahead and look at a demo of temporal tables. So I'm using my college football database. And what I'm going to do is just take a backup of this win-loss major NCAA schools table into this backup table. I'm going to create a table and I'm going to create a primary key because that's a requirement for things that are involved in a temporal table system versioned scenario. And then I'm going to insert the records from win-loss major NCAA schools into the backup table. So let's go ahead and do that part. And you see I've got 298 rows in a backup table. So we're going to go ahead inside this college football database and create a schema. And that is a preference because the system version table or history table can be collected all in its own collection of tables based on the schema. So then we're going to change this existing table I made, and you're going to add a system start time and a system end time column with the required defaults. And you have this period for system time, system start time, and end time as part of your syntax for this. So I'm going to go ahead and run this. And then you actually have to turn on the system versioning once everything is actually set up. And in this case, you can see I'm turning on the system versioning for history.win-loss major NCAA schools backup. You don't have to name the table, but I would just suggest you do, because if you don't, SQL Server is going to give it a name, and yours is probably going to be far better. So now let's take a look at what we have in these tables. So this top table represents my temporal or source table. And what this is just a list of schools alphabetically. You have their start year and end year for when they started and stopped their football programs. And then out to the right, you have various data about how many games they played, how many wins, how many losses, how many ties. You also have things for like overall winning percentage, et cetera. So notice down here, we have nothing returned for our history table because we haven't made any changes to the temporal part yet. So we're going to make some changes. As you see in this data set, apparently Air Force starts playing football in 1957. We're going to change that to 1900. And then this school, Akron, nobody really cares about except people who go there because their football program isn't very good. So we're just going to delete them from the data set. And now we're going to take a look and see what does the temporal table look like and what does the history table look like. So this top query says, give me everything from the backup table where school is Air Force or school is Akron. So as you see, we have Air Force here. The start time or start year is now 1900 for this particular school. And we have no Akron because we deleted it. Down here in the temporal table, or I'm sorry, the history table, system version table, we have Akron. Here's our start year of 1957 that we changed. If you scroll all the way to the right, you can see a system start time and a system end time. This represents the time range for which this particular version of the row existed. And here you also have Akron. So these values will show you when this particular row existed in the data set at all. So in the example I gave of massive changes that you didn't really want, they were mistakes, you can use the system version history table to recreate what your table was supposed to look like or what it did look like at any particular point in time. You can also, like I said, look for trends based on changes in the history table and that sort of thing. I'm going to do a little post-demo cleanup. So that is your system version or temporal tables. Any questions about that? Okay, so one thing I didn't touch on or mention yet is that these temporal tables can be a replacement for triggers as a means of tracking changes. Now, one thing that temporal tables system versioning doesn't do is it doesn't tell you who did it. But for that, you can look at Aaron Bertrand's solution that I give you a link to inside MS SQL Tips. And he has a great solution that I've actually helped implement before so that you get not only what changed and when, but who did it. So the next section is about permission enhancements, and this just focuses primarily on SQL Server 2014 because this is where I can find some of these things for this particular presentation. So the connect any database permission grants connect permission to a login, and it can be combined with other permissions to provide additional capabilities. So for example, if you combine this permission with grant server view state, then a login can monitor performance via DMVs without actually being granted access to the data in the database. So it gives you a bit of a permission security feature there. The select all user securables grants select permissions to all objects to which a login has access. So when you combine this with connect any database, this is really just a simple way to grant read permissions to all databases at the server level. So why would you do this? Well, one reason might be that you have a group of Power Business users who do reporting or a dedicated SQL report writers, and you want to give them select permissions to all the databases, and that's all you want to be able to give them. So they can then use these permissions, which are easy and quick to set up, to write their own reports without requests to an IT department. And the additional great thing about this connect any database is that it grants access not only to the current databases that are made on the system, but also any future databases. So the next kind of category that we're going to look at is various T-Sql enhancements. So there are quite a few of these. Most of them come from SQL Server 2016. We have things like drop if exists, which greatly simplifies scenarios where you need to see if an object exists and drop it before you create the object. And this might be useful in scenarios or situations where you're deploying new SQL objects via scripting. A variation on this is the creator alter syntax. So using this syntax, if the object exists, then it will be altered to match the new definition that's contained in the script. If the object does not exist already, then it will be created. This, however, does not, please note, work for tables. You can't use create or alter for tables. You also have JSON format support in SQL Server 2016, and there are a number of functions that you see there, syntax for JSON. At SQL Server, Microsoft has worked hard to try to extend the T-Sql language in SQL Server for developers. And so this support for JSON is one of those ways. So if you need or want to explore the use of JSON with SQL Server, you can do that. The alter table feature now has an online feature that has just a fair amount of restrictions, but it does seem like there is some general usefulness to using the syntax change. The Microsoft docs do indicate that you can use this new syntax for things like column changes related to data type, column length or precision, sparseness, and collation. And you can make these changes while the table remains online, so you're not blocking users and sessions out while you're doing these things to tables. Also, index creation can now be done inline when you're actually creating the table, rather than just creating an index after making the table. I think this just makes the SQL syntax shorter and easier to do than creating index after the table creation using alter table, or create index on so-and-so with these columns. So for columns where you're going to need to index from the very beginning of the table creation, I think this is a faster, simpler way to get those indexes in place. Also, there's a number of string functions that were introduced in SQL Server 2017. And the one I'm going to talk about is that trim function there that you see. So back over in SQL Server Management Studio, we're going to take a look at T-Sql Enhancements. So the first thing I'm going to do is demonstrate this drop if exists that we talked about and we actually saw earlier. So if you just come into a database and create a table because you want to do a little playing, and you do your playing and a week or two goes by and you don't know whether you've promoted this or not, and you come in and you run this again, it's going to blow up. Hey, SQL Server says there is already an object named my test table in the database. Well, how do we get around that? I mean, that sort of thing can really blow up a SQL script for deployment, right? And then if this table doesn't exist and you're trying to deploy stuff that depends on the table, then that breaks and you have a big mess. So the previous method, or one previous method to deal with this, is what you see on the screen here, this if exists. So this says, if I find this object, I'm going to run this begin and end, and I'm going to drop the table. And that works fine, but it's longer. There's more work involved to do this. What if you could just have a one-line statement? Drop table if exists, and then you put the name of your table. Huh, magic. Magic that makes things better. So the next thing that we talked about from the slides was creator alter. If I go into this DBA utility. I'm going to make a stored procedure called get SQL Server versions. And simple stored procedure, just for demonstration purposes, it's just going to select the top 5 rows from SQL Server versions. So we're going to make that. Then we're going to run it. And you see I have the first 5 rows of information here. So here I'm going to run this same creator alter, but now I'm going to say select top 50. I'm going to run that. And now you can see in the lower right corner here, I have 50 rows. So the next thing that we talked about in the slides was inline index creation. And what I'm going to do is I'm going to go into my database. I'm going to drop my table if it exists, like we saw earlier. And I'm going to create this table T1 with a column. And right here, I'm going to create an index called IX1 on column 1. And in this case, because it's filtered, I have this where clause. Works like a charm. Now we have 2 columns. We have index IX1. It's non-clustered on both columns. And that works. Table 3, we have 2 columns, IX_1. Now we have a unique non-clustered index on those 2 columns. Now I'm actually going to make a unique clustered index on those 2 columns in another table. So now you can see from this example, just a quick, easy way to make indexes that you know you're going to need right when you make the table. So the next thing I talked about or mentioned in the slides was the trim function. So what this does is it keeps us from having to nest left trim and right trim. So these first 2 rows give you the same output down here in the bottom, but this one is much easier to read and understand what it's doing. The left trim here is going to take out this space. The right trim is going to take out everything that's over here. And when you look at, data length for trim, you have 14. Then the left trim takes out just this space and leaves you with 18 bytes. The right trim leaves you with 15. And then when you combine these, you get the 14 bytes, same as with just the trim function. So I just think trim is easier. You don't have to nest functions that way. And so it's less confusing about what you're actually doing. You can also do things like get rid of letters within strings. So this declares a string of application A, and this says trim A from the string. So you get application A, but no A at the beginning and no A at the end. And here you see the links for these particular types of, or these particular result sets. Any questions about that? Okay, so the next thing is, where can I find all this? Where did you find it? Where can you find it for yourself? So there's a list of links that I use to find this information. And that first one there covers everything from that's new features from SQL Server 2016 up to 19. And then you have a previous versions link, which you guessed it does everything prior to SQL 2016. One of my favorite sites is a place called MS SQL Tips. And almost every time a new SQL Server version comes out, you'll find one or more articles on MS SQL Tips about what's new in version, SQL 2022 or whatever is going to come out next. There are places like blog.pythian.com where you can also find these kinds of particular posts about what's new features in SQL Server 2019. There is a link in here about machine learning, because that's an area of interest for folks, and SQL Server Microsoft community has been putting a lot of effort into that. And then you have some bit.ly links there for things like setting up a listener in a multi-subnet scenario for always on availability groups, and the SQL Shack article on distributed availability groups. So I have just kind of some honorable mention type features that didn't make it into this particular version of the presentation. We have things like in Memory Oltp. There have been some enhancement to this since its release. I think there are still a fair number of things that restrict the use case, but it can be useful for some workloads. Again, here's a mention about machine learning. You might use this for predictive analysis, sift through data, find trends, extrapolate the future based on the data that you have right now. We have some security features like backup encryption, always encrypted, dynamic data masking, and row level security. Always encrypted protects data at rest and in transit between SQL Server and the client. Dynamic data masking does things like protect social security numbers or emails from being completely exposed in applications. And row level security is useful in scenarios where you have multiple departments who have to access a single database and single sets of rows. And so it can be used to make sure that each department can only access the rows that matter to it and not see the rows from other departments. And I mentioned earlier at the very beginning, column store indexes. I didn't have the ability to put this fully into the presentation right now, but I really do think because of the enhancements since SQL Server 2012, this is a great feature that can be very useful for reporting. So I would encourage you to look at some of these other, at some of that feature, some of the things that feature can do for you as well. So in summary, we've discussed high availability and disaster recovery, things like changes in SQL Server for availability groups, accelerated disaster recovery, which helps you get SQL Server back online quicker without any action from yourself. We've looked at performance category for a couple of features in the collection of features called intelligent query processing. We took a look at query store. We looked at some troubleshooting features that are going to give you some additional help when you're trying to figure out what happened to this data and how can I fix it. We looked at some permissions that allow you to do some things quicker than you could do them before. And we looked at a number of T-Sql enhancements that help you write less SQL so that you can get things done quicker. So with that, the presentation at this point is actually finished. We'd certainly appreciate your attendance, and we'll take any additional comments or questions after that.